I'm going to be making a truss structure for a telescope tube. The original design I was going to use a metal tube. This is stainless, but I was going to use an aluminum and have it welded up. Well, I found if I can get the weight of the thing down to a good bit, I make some real significant improvements in design, reducing counterweights and everything. So what I want to do is I want to replace this metallic or a metal tube like this by a graphite-epoxy composite. This is an aircraft industry standard lightweight construction. The only problem I've got is that if I make a mold for the outside, I have to make a mold for the inside in order to get the compression in the fabric. I've solved the problem for the outside and actually for the inside also. In order to have a tool for the outside, I found that I can go to a standard irrigation plumbing and get an irrigation pipe. This is 1.25 inch size, that's the nominal size, which is the inside diameter, schedule 80. Now normally we use schedule 40 and we use schedule 80 PVC pipe for normal irrigation. The thing that I need to do then is to make a tool out of this is to split it down the middle. Basically I've already done some of these things. This is the tooling that I would use for it. This is the same pipe, but I've set it up in a bandsaw with gates and I was able to rip through and basically make essentially a two-piece mold. The tricky part's always been how do you make the mold on the inside. Well, I've already made a mold. I've got a construction that will allow me to take it apart after the part has been laid up. This will have a wrap of fabric, will be set in place, and it'll be clamped. And I'll do that later. But the process that I use for this is I use a copper, a 5/8 inch copper pipe for stiffness, rigidity, and a series of shims in order to build up the inside dimension so that I can wrap what amounts to a spiral wrap. So this is basically going to be the construction to do the laminate. I had to get some kind of a shim material that would be fairly slippery, and actually I found that there is a kind of weather strip. It's a self-sticking plastic. It's sort of a nylon-like material. It has adhesive on it, but I found I pulled that off and used a solvent to clean off the adhesive because I didn't want that basic thickness to it. I basically applied those strips right to the exterior. There are many ways of doing it, but this is the way that I was experimenting with it. So I'll be able to take these segments and wrap them around so that I basically built up a core. Now the key is to apply or put the spiral wrap. So to put this on, actually you almost have to screw it on once you get this thing, once you get it started. Actually, as it works out, as you screw it, it tends to expand. So you try pushing it on, it'll go on to a certain amount, but at a certain point it'll resist. So by torquing it, it expands it so that you can actually slide it on. So it's actually not that hard with the clamping strength out of it. So this is going to basically work. When it drops in, it'll drop in this manner. Now, in order to just check it all out, now to actually verify that the diameter is set right, you could take some calipers and try to measure it. But actually, a much easier way is to set up a strip. You measure what the circumference is, and you know what you need in the way of a circumference, so you can make it a simple test strip and then wrap it around and just see where it falls. This wants to fall somewhere within the black mark, and that looks like that's pretty good. So that's going to work fine. Actually, this has enough spring to it that by the time I compress it, I should get a pretty good compression on that. Basically, this is a graphite-epoxy fabric, very, very strong material, very lightweight. When I wrap this on here with the resin, I'll impregnate that with resin, and this will go around, and it's sized to give me 3 rotations, so it'll end up pretty much a net size, and then I can just drop it into the mold until it sets. Okay, I've set out a saran wrap here. Now this is going to be my resin barrier, so this will allow me to apply the resin directly onto the part. Now I'll probably put a strength of mylar tape along the edge just to make sure it stays closed. That's fairly redundant. Okay, now I've got the mylar tape on there, and I also taped the ends, sealing the saran at the ends because I might get some resin flowing back. Now then, the next thing I'll have to do is to set up for the layup. I'll have to spray a parting agent on the. These have been already polished and waxed. That's going to sit in the central part there, and then when I clamp it, to do the layup, I've got a work board here that I've wrapped in wax paper. That'll be kind of a parting agent. What I'll do is I'll apply a layer of epoxy. I'll just paint it onto the surface, spread it out. It's not going to take very much to the full size I need. Then I'll basically lay the graphite fabric onto it, wipe it in, make sure that it absorbs the moisture so it's got a nice uniform thickness. Then I'll have the mandrel set up so that I can apply it and then basically wrap the whole thing up as I go up. Okay, we're going to start our layup of our test assembly. I've got 2 parts of epoxy here. This is the basic epoxy, and this is basically the catalyst part. The ratio in this particular one is 3 of this to 1 of this, the hardener. Actually, this mixing cup will be almost wasted, but I will need to put a very small amount. I only need about 1.5 inches square inches. So I'm going to put this small part out in here. I think if I'm working in larger quantities, it'll be an awful lot easier. Then I'll take the batch and start mixing it. I've set up, this is the wax surface, and I want to lay it so I can roll it up. So the mandrel will be set up like that. Now what I'll do is I'll lay down a coat of resin. Okay, this is basically all set up. I'll just peel this back out of the way and start to lay out resin over here. This is not going to need to be too thick, basically, but I'll brush it out to the area that the cloth is going to cover. Okay, I've basically got enough on here on this wax paper. It's fairly uniformly distributed, so I've got at least a good start. Now I'll set the fabric down. And I'm going to basically brush it in here so that the resin impregnates into the fiber. We'll try to move outwards so I can leave the outside a little bit dry. At least that's what I think, and that's one reason for doing this test part, so I'll know what to expect when it comes to making the 5-foot long ones. Okay, that looks like it's pretty well all wetted out. Got a little bristle here which I don't need. That's out to try. Now my theory is that I can wrap this on here, so I want to wrap it fairly tightly to get a good weave. Okay, the fibers are well impregnated. This is going to be fairly dicey when I do it in the 5-foot length. Okay, that looks like that should fly. These have already been waxed, and then I've sprayed it with a Teflon coating. Now I'm going to try to drop this in. Now this is going to fit into basically there, and drop that on. And it feels like it's holding pretty good. Okay, I can see there's some epoxy is squeezing out right now. I have to work out a system to minimize that as much as possible. But actually the tool looks fairly good. Okay, I've let this sit for several days, and this should try to extract this. Part came out okay. Now we want to take out the other part. That seems to come out pretty easy. So we have the tube in here. Let's see if I can pry this open. Yeah, they open pretty easy. It's not too bad. It's actually turned out came out pretty darn easy. Looks like a good finish. I can just sand those off. Very good.